Yeah, thank you so much and welcome to PEG Tutors. You can subscribe to our Facebook page, PEG Tutors. Just type PEG Tutors. You'll see it, click the subscription button and ring the bell as well. So that anytime we post our videos, they would notify you. Okay. So today we're going to be dealing on further mathematics. Yeah, binomial expansion. Okay. You notice very well that when you are solving mathematics and you have a question such as this, it is very, very easy to expand this. Just open the bracket, x plus y, then x plus y. Multiply the two, you would have x squared plus xy plus xy plus y squared. So at the end of the day, you have x squared plus 2xy plus y squared. In other words, you have three terms left. Each of the terms have their coefficient. Here you have the coefficient as 1. Here you have the coefficient as 2. Here you have the coefficient as 1. 1 to 1 in their coefficient. It is simple to expand because, as you can see, the power is small. But what about cases where they give you algebras in brackets and they with a higher power and you're expected to expand? How do you start with that? That's where binomial expansion comes into place. In binomial expansion, we'll be using two methods for the binomial expansion. Number one, we use the Pascal's triangle, and number two, we also use the binomial theorem. So, but for the sake of this video, we're just going to be basing for this particular one, on Pascal's triangle. After this, we'll go to binomial theorem. So for example, you are given something like x plus y, the same thing, but raised to power 5, for example, for you to expand. You can't just start by saying x plus y, x plus y, x plus y, x plus y, 1, 2, 3, 4, x plus y, into 5 places. Before you finish expanding, this time would have gone and everything. So that is why this binomial expansion is quite very easy. So how do you start by expanding this? Very simple. Just multiply the two variables inside the bracket and add them up. Multiply the two variables inside the bracket and add them up. For example, x times y will give you x, y. But for the first term, x should be raised to power 5 and y should be raised to power 0. So why x decreases, y should be increasing as you are multiplying across board. So we have x raised to power 5, y raised to power 0, plus x raised to power 4, x reduces and y increases, y raised to power 1, plus x raised to power 3 now, and y raised to power 2. You see? So as x is reducing, y is increasing, plus x raised to power 2, then y raised to power 3, plus x raised to power 1, y raised to power 4, then plus x raised to power 0, y raised to power 5. Okay, let me put it this way so that we can have a log for plus x raised to power 0, y raised to power 5. In this case, now you can see that y raised to power 0 is 1. 1 times x raised to power 5 will leave x raised to power 5 here, plus y raised to power 1 is still the same thing as y. Okay, anything raised to power 1 is that same value. So we have x raised to power 4, then y, plus x raised to power 3, y raised to power 2, plus x raised to power 2, y raised to power 3, plus x raised to power 1 is still x, then times y raised to power 4, plus x raised to power 0 is 1, and y raised to power 5 is still the same. So we have y raised to power 5. Now at this point in time, we have to impute our coefficient. Remember, for this power 2, we had coefficients 1, 2, 1. But if you check this particular multiplication, there is no coefficient. Coefficient of this, how do we get it? This guy is supposed to have a coefficient 1, 2, 3, 4, 5, 6. All the systems are supposed to have a coefficient, but as it stands now, there's no coefficient. So how do you find out what coefficient they would be? Now, to find out the coefficient you use is you now use Pascal's triangle. So the question is, how do we plot Pascal's triangle for any factorization that is raised to the power of 5? So how do we do that? You start constructing the Pascal's triangle like this. So first you have a 1. Okay, you have a 1 and assume before the 1 there is a 0, and after the 1 there is also a 0. So 0 plus 1 will give us 1. Write the 1 down here, and then 1 plus another 0 on this side will give us 1. So you have 1, 1, 1. Okay, so assume another 0 here, also assume another 0 on this side. So 0 plus this 1 that is here will give us 1. 1 plus 1 will give us 2. 2 plus 0 that is here will still give us 1. So you see, it's gradually forming a triangle. So you have, assume another 0 on this side. 0, 1, 2, 1, 0. So 0 plus 1 will also give us 1. Write it down here. 1 plus 2 will give us 3. 2 plus 1 will give us 3. 3 plus 0 will give us 1. So you see, we are going gradually. Now go back here again. Assume 0 to be here. 0 plus 1 will give us 1. 1 plus 3 will give us 4. 3 plus 3 will give us 6. 3 plus 1 will give us 4. Then 1 plus 0 will give us 1. So we are gradually going. Then 0 plus 1 again will give us 1. 1 plus 4 will give us 5. 5 plus 6 will give us 10. 6 plus 4 will give us 10. 4 plus 1 will give us 5. And 5 plus 0 will give us 1. Now, so you have 1, 5, 10, 15, 10, 5, 1. Now, the question is, which of these numbers that I've just constructed right now should I use? Now, this guy is zeroed out first. This point 0, this is where you start your counting from. So you start from first number for power 1 expansion, second power, second for power 2 expansion, third for power 3 expansion, fourth for power 4 expansion, then fifth for power 5 expansion. So what concerns us is power 5. So this number here is number you are going to be using as the coefficient of this expansion that you are seeing here. So now I can go back and impute this coefficient in my already expanded value. So I come here and put it down. So lastly, that will be, which means the first term here would have 1, the second term here will have 5, the third term will have 10, and all that. So let us put it together. We have x5, coefficient is 1, so we have x raised to power 5 plus, for x raised to power 4 and y, the coefficient is 5, so we have 5x power 4, then y, plus 10 x power 3, y2, plus we have another 10 x power 2, y3, plus another 5 x power x power 4, so x power 1, y4, then plus y4. So that is all. I believe it is quite easier for us to understand. Well, before I leave, I think I would have to give you an assignment for you to do by yourself. So we have, for example, just solve this by yourself. You have a plus b all raised to power 7. Try it and see what it gives to you. Thank you.